In this section, we're going to explore classes, objects, and null checks. We'll start by taking a look at what is a class. Then we'll talk about how to create a class to represent a plant. Then we'll discuss what objects are and their relations to a class. Then we'll look at an example of objects and collections of objects. And we'll finish up with null checks. So in this video, our focus is on classes. So we're going to take a look at what is a class. Essentially, a class is a noun. We'll consider some examples of classes. We'll talk about properties, and then we'll talk about getter and setter syntax as well. So first of all, what is a class? A class is a noun, or a thing that can be described with properties and behavior. Properties would be adjectives that describe a class, and behavior are the verbs or the things that a class can do. So I have a few examples here. The traditional example that you'll see in an introductory programming course is a car. So a car is a noun, and its properties can be its color, its year, its make, and its model. The things that describe that car. In other words, if you go to the grocery store and you drive, and then you go back out to the parking lot, you need to find your car among the dozens of other cars that are in that parking lot. So you'll probably find your car, if you don't remember where you parked it, based on the color, the year, the make, and the model. So you'll probably start with the make and the model. So maybe a Toyota Corolla. Okay, that's going to eliminate a vast majority of other cars in the parking lot because many of the other cars are not going to be Toyota Corollas. Then you see one that is silver, and you think, okay, mine's silver, but wait, there are two that are silver. So then you might go down to the year and say, well, mine's a 2013, this one's a 2014. Or if you're really that close, you might say, which license plate is it? Something like that. Similarly, a person also fits this paradigm of a class. A person is a noun. A person has a first name, a last name, and possibly a phone number. Or maybe multiple phone numbers. You can probably think of other examples of classes as well. A dog or a cat, something like that. A class is essentially a template, and the template is defining what the name of the class is, and then it's defining that there should be properties that describe this class. Very important, a template is not providing a value to those properties, it's simply saying that these properties exist. It might define a default value, but an object is where we actually say this person has this specific first name as opposed to just an empty string or a null first name. Or this car is a silver 2013 Toyota Corolla as opposed to a car will have a make, model, year, and color. We'll talk more about that when we get into objects. But for now, just remember, a class is a template. We're saying what the class is, and we're saying what properties belong on that class without giving them specific values just yet. Okay, properties. The adjectives that describe a class. We spoke earlier about make, model, year. In Kotlin, we can define these all in one line, which saves us a bit of typing. So, over Java, to be honest. So if we take a look at our plant flashcards, we made a plant class earlier. You see we have the word class plant, and we took advantage of this one-line nature by saying, okay, for the noun plant, here are the adjectives or the properties that describe that plant. A global unique identifier, some kind of numerical ID, a genus, species, cultivar, and common name, so the scientific name and then a common name in local language. A height, but we're defaulting height to 0 if height is not specified. So that's how we can define a class in one line. Now in Java, we typically need multiple lines, and this is one of the cases where Kotlin is a bit less verbose than Java. So in Java, we'll typically define multiple lines, and we'll give each class a getter and a setter. So what is a getter and a setter? Well, a getter and a setter, if I can draw an analogy about how plants work, a getter and a setter is like this stomata that we see here. A stomata is a valve. What we're looking at on the right is a zoomed up tomato leaf, or tomato if you prefer. At the moment it appears to be closed. It has some flaps in there that essentially have sealed it shut. Well, this is a valve that's on a leaf of just about any plant in the world. And that valve, if the plant has water, has access to water, that valve will be open and let steam out. That steam it's letting out is creating a vacuum which pulls up water from the ground, and that's how leaves can be green. Leaves are green because of chlorophyll. Chlorophyll is made mostly out of the macronutrients of life, carbon, hydrogen, oxygen, and nitrogen, but it also requires one element of magnesium, and magnesium has to come from the ground. It's not airborne. So magnesium has to be pumped up through the plant's inner workings, through its inner plumbing. So if you see a tall tree with green on the top, that means an element of magnesium was pulled up all the way from the ground to make that green color that you see. So stomata goes open when there's water. There's sufficient water at the root level to create this vacuum and pull water vapor up through the plant. But what if we're in drought? If we're in drought, that stomata closes and it seals off the water vapor, keeping it in the plant so that the plant can conserve water. That's why a plant that often is low on water is wilting. It's wilting because those stomata are closed. So the stomata is the gatekeeper, and it works well in a deciduous plant, a broadleaf plant. Doesn't work so well in most evergreens and needle plants because needles can't wilt, so those stomata are stuck open. So in the Java programming language, we would typically protect our properties like the stomata protects the water in a plant. We protect the properties with a series of getter and setter methods. But the truth is, the vast majority of the time, those getter and setter methods are just allowing open access to the internal properties of the class anyway, so it just really became a laborious typing experience. So in Kotlin, they went with that concept of the one-line class, as we saw with plant earlier, where we simply define it all in one, and we assume that the getters and setters are not going to provide any additional protection. Do we still have the opportunity to provide that additional protection? Yes, we do, if we want. In Kotlin, we can have a more traditional Java-like getter and setter, and it's implemented in a way that we see in C#. And that is, we have a private inner property called underscore genus in this case. Then we have a public outer property without the underscore, but otherwise the same name, and we give it a type. Immediately after that, we have a get, open and close paren, and then equal. And this essentially is defining what a getter method will do. A getter method will return the internal private variable genus, the value that's inside there. The setter value means we are accepting some new value for this genus. And so we accept the value like so, and then we do a simple assignment statement like so. Now, to make things easier, we don't have to invoke this get or set method explicitly. All we need to do is access the public outer property called genus without the underscore, and if we have that as part of an assignment statement, if we have it on the right of an equal sign rather, it will implicitly invoke the get method that's defined here. If we have this word genus on the left of an equal sign, then it is going to do an assignment to that genus, which is going to invoke this set method here. So in our case, we don't need to worry about this just yet, and in most cases you won't need to worry about it, but I do want to introduce that while we have this concept of a one-line Java class like so, we still can get the getter setter functionality from Java if we want it, but it's more common to only do that where required. So if we require it, we can drop to this level, but typically not required.